Welcome to Wisdom Outlined Coaching. Our mission is helping you learn. My name is Askar Khan, your math coach. In this video, we will learn what are the different operations that we can apply on real numbers. So let's dive into the lesson. In our previous lessons, we learned what rational numbers are, what irrational numbers are. Rational numbers and irrational numbers together are called real numbers. And in this lesson, we will see what are the different operations that can be applied on real numbers and what is the result of those operations. Let us look at the addition operation on rational numbers. Is 2 a rational number? Yes. Plus, is 8 a rational number? Of course, we know that any rational number is a number that can be expressed in the form P over Q, where Q is not equal to 0 and P and Q are integers. We learned that in video lesson number 1. 8 plus 2 is 10. Is 10 a rational number? Yes. So, when two rational numbers are added, the sum is a rational number. Correct? Okay. Let's understand this. Is 10 a rational number? Minus 5. What do we get? 5. So, are the subtraction of two rational numbers results in a rational number? Yes. So, the difference of rational numbers will be a rational number. Fine. 2 over 5. Is this a rational number? Yes. Times 3 over, let's take 7. Are these two rational numbers? Yes. And what do we get when we multiply them? We already know how to multiply two fractions. Multiply the numerators, multiply the denominators. 6 over 35. Is this a rational number? Yes. So, when the product of two rational numbers results in a rational number, isn't it? Fine. Let's look at this. Is 8 a rational number? Of course. Divided by 4. Is 4 a rational number? Yes. So, 8 divided by 4 is 2. Is 2 a rational number? Yes. So, when two rational numbers are divided, the quotient is a rational number, isn't it? Of course, you can't divide by 0. That's an exception. So, did you observe that the sum of two rational numbers is a rational number? The difference of two rational numbers is a rational number. The product of two rational numbers is a rational number. The quotient of two rational numbers is a rational number. So, we say that rational numbers are closed under addition, subtraction, multiplication and division. Do you get it? Now, what about irrational numbers? Let us see. Let us look at the operations on irrational numbers very carefully. Is root 2 an irrational number? Yes. Okay. Plus, let's take another root 2. Is root 2 an irrational number? Of course. 1 root 2 plus 1 root 2 is 2 root 2. Is 2 root 2 an irrational number? Of course, because when a rational number is multiplied by an irrational, it will still be irrational. Fine. So the sum of two irrational numbers is a irrational number. Fine. What about the difference? Let's look at root 2 minus root 2. What do you get? We get 0. Is 0 rational or irrational? It's a rational number. So the difference of two irrational numbers may be irrational or may not be irrational. Understand? So the sum or difference may not always result in rational or irrational numbers when it comes to irrational addition or subtraction. Let's understand again. Root 2 times root 3. What is the product? It's root 6, which is irrational. Okay. What about root 2 times root 2? It is square root 4, which is 2, which is rational. So do you see here now? The product of two irrational numbers may result in an irrational number, or it can be a rational number. So the result is not always fixed. It depends on what are the irrational numbers that you are multiplying. What are the irrational numbers that you are subtracting? What are the irrational numbers that you are adding? Let's look at division now. Root 17 divided by root 17. What is the answer? It is 1. So the quotient of two irrational numbers can land up with a rational number, or it can also be an irrational number. So when it comes to irrational numbers, the sum, the difference, the product, the quotient may or may not be irrational. Got the point? So we say that irrational numbers are not closed under addition, subtraction, multiplication, and division. Fine. What about when a rational number is added to an irrational number, or subtracted, or multiplied, or divided? Let us see. Okay. Is 2 a rational number? Yes. Is root 3 an irrational number? Yes. And what is the decimal representation of an irrational number? It is non-terminating, non-recurring. That means the decimal will go on and on and on without repeating. Watch my previous video lessons in detail for decimal representations. Now let's add them. When you add a rational number with an irrational number, the sum is irrational. That's obvious because root 3 is irrational. The decimal representation goes on and on and on without terminating, without recurring. If you add 2 to it, it will still go on and on and on. So therefore, a rational added to an irrational number is an irrational number. The same thing goes to minus root 3. What do we get? Whatever it is, we get an irrational number. Understand? Okay. What about multiplication? A real rational number multiplied with an irrational number. It is 2 root 3. It is still irrational. Understand? What about division? Let's take 2, which is a rational number, divided by an irrational number, the quotient will be irrational. So now we know when a rational number is added to an irrational number or subtracted from an irrational number or multiplied or divided, the result will be an irrational number. Fine. Now, how do we add two real numbers then? How do we multiply? How do we divide? Let us see the operations now. Let's work out this example. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So let's first write this down as a mathematical problem. 2 root 2 plus 5 root 3 and plus root 2 minus 3 root 3. Okay, let's put the same radical signs together. So let's rewrite them again. 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. We have just rearranged them, nothing great. Now, can I write this root 2 as 1 root 2? Is the same thing. So, when the radicals are same with the same numbers inside them, the numbers outside can be added. It's like terms in algebra. So, 2 plus 1 is 3. So, 2 root 2 plus 1 root 2 is 3 root 2 plus 5 minus 3 is 2. So, 2 root 3. That is the answer of addition. Get it? So, whenever the radicals are same, they can be added or subtracted. Let us multiply two irrational numbers. Don't worry about the example number. How is it 13? Focus on the problem. Multiply 6 root 5 times 2 root 5. Now, whenever you are multiplying two irrational numbers, you can multiply them if the radicals are the same. And you can multiply the numbers inside them also. So, let's multiply. 6 times 2 is 12 times root 5 times root 5 is root 25. Because the radical signs are same, I can multiply the numbers inside them. 12 times, can you tell me what is root 25? It is 5. Very good, because 5 times 5 is 25 and square root 25 then will be 5. So, 12 times 5 is 60. So, 6 root 5 when it is multiplied by 2 root 5, what's the answer? It's 60. Got it now? How we multiply? Let's see how to divide. Let's look at this. Divide 8 root 15 by 2 root 3. So, let us write it in a way where we can understand. 8 root 15 divided by 2 root 3. Okay, but let's simplify. 8. Can I write root 15 as square root 3 times 5? Okay, divided by 2 root 3. Can I split the roots? You have studied that in lower grade, the algebra of 8. So, can I write this as 8 times root 3 times root 5 divided by 2 root 3. When we say 2 root 3, it is same as 2 times root 3. Okay, now observe, root 3 divided by root 3 is 1, and 8 divided by 2, 1 times is 2, 4 times is 8. So what is the answer? 4 root 5. So 8 root 15 divided by 2 root 3 is 4 root 5. The only thing is, do you know how this root 15 was simplified, was split? So this is how you divide two irrational numbers. Let us see how to simplify irrational numbers. Simplify 5 plus root 7 times 2 plus root 5. Now, how do we open these brackets? This is one irrational number. This is another irrational number. We need to multiply both of them, and they both are in the brackets, in parentheses. Now, the method is, take each number from one bracket, the first bracket, and multiply with every single number in the second bracket. Now let us see how we do that. 5 times 2 is 10, plus 5 times root 5 is 5 root 5. Good. So we took the first number 5 and we multiplied with every single term or every single number that is in the second bracket, and we are done with 5. Now we will move on to root 7. Plus root 7 times 2 is plus 2 root 7. Got it? And plus times plus is obviously plus. Root 7 times root 5 is plus root 7 times 5, 35. Understood? Now, do you see, are there any radicals with the same numbers in them? No. So we cannot add any of them, and that will be your answer. Got it? How you open the brackets? Now let's look at another one. Let's simplify this. 5 plus root 5 times 5 minus root 5. In the previous example, we saw how to open the brackets. Take every term in the first bracket and multiply with every single term in the second bracket. So let's go ahead carefully and slowly. 5 times 5, 25. Okay. Then observe there's a negative sign. Plus, when there is no sign written in front of the number, it's plus. Plus times minus is what? Minus. Okay, so we got rid of the sign. 5 times root 5 is 5 root 5. So we took the 5 and we multiplied with every single term in the second bracket. So we are done with 5. Now we are moving to root 5. Now look at the sign again. This is plus. What is the sign before the 5? It's plus. Plus times plus. That's plus. Okay, now we don't have to worry about the sign. Root 5 times 5. It's 5 root 5. Isn't it? Okay. Let's go back to the sign again. Plus times minus is minus. So now we dealt with the sign. Root 5 times root 5 is root 5 times 5, which is root 25. Or can I write this instead of writing that as root 5 squared? Any problem? No, because root 25 is root 5 into root 5, which is root 5 squared. We will see why we are writing like that. Now, so we open the brackets. What do you observe? Do you see the same radical signs with the same numbers inside? So we can simplify them. Minus 5 root 5 plus 5 root 5 is what? Is 0. Because minus 5 plus 5, 0. So now we are left with 25 minus square root 5 the whole squared, which is nothing but square root 25, which is square root 25, which is how much? 5. So square root 25, which is basically 5. So 25 minus 5 is 20. So that is your answer. Fine. But observe one more thing. Can you see here? 5 plus root 5 times 5 minus root 5. Is this 5 squared? Yes. Minus root 5 and root 5. Is this root 5 squared? Yes. So in general, can we say if anything is in the form a plus b times a minus b, can we say it will be equal to a squared minus b squared? It is. So next time when we come across such situations, we don't necessarily have to open the brackets like this. Anything in the form a plus b times a minus b can be written as a squared minus b squared. We will use this in one of the examples. Okay, understood this? Let's move on to a next simplification. Let us simplify this. Root 11 plus root 7 times root 11 minus root 7. We know how to open the brackets. Take the every single term in the first bracket, multiply with every single term in the second bracket, then simplify. You know the method as per the previous examples. But before you even jump to do that, observe. Observation is the key to learning. So enhance your observation skills so that you will become a self-learner quickly and less dependent upon your teacher. Okay? So let's move on. Do you observe? Is this in the form a plus b times a minus b? And we learnt in the previous slide, a plus b times a minus b is equal to a squared minus b squared. So instead of opening the bracket with every single term, can we simply apply this identity? Our a is 11 and our b is, our a is root 11 and our b is root 7. So we know this. So according to this then, it will be root 11 squared minus root 7 squared, isn't it? Root 11 squared is square root 121, because root 11 times root 11, root 121, minus root 7 squared is root 7 times root 7, which is root 49. Okay, next step, root 121 is 11, minus root 49 is 7. So 11 minus 7, 4. So that's your answer. So root 11 plus root 7 times root 11 minus root 7 is 4. Again, observe. Observe. Root 11 squared. Finally, what is it? Root 11. Root 7 squared. Finally, what is it? Root 7. So do you observe the root and the square? If you eliminate this, the answer is 11 for this, isn't it? So can we generalize this and say root 11 squared? What will it be? I can simply cancel out the square root and the square. It is 11, as we saw. Root 7 squared, what is it? Can we cancel out the square root and the square and we say 7? Okay, in the same breath, the numbers have nothing to do with the problem. Tell me now, root 83 squared, what is it? 83. Root 525 squared, what is it? 525. Getting the point? Root 17 squared, what is it? 17. You understand now? So you can observe and derive various mathematical techniques while you are learning your lessons. Okay? So do you understand now this identity a plus b times a minus b? What is it? It's a squared minus b squared. Remember this, because you will be using this a lot in the coming lessons. Okay? Let's try another example. Let's try this and simplify. Root 3 plus root 7 the whole squared. What do we mean by the whole squared? Can we write this as root 3 plus root 7 times root 3 plus root 7? Is it the same thing? It is, because squared means the same thing is repeated twice. Now we know how to open the brackets. Every term in the first bracket is multiplied with every single number in the second bracket. So go ahead. Root 3 times root 3. Can I say it's root 3 squared? Okay. Plus root 3 times root 7. Is it root 3 times root 7? Let's put it that way. Fine. We finished with root 3. Now we will move on to root 7. Plus root 7 times root 3 is same thing, root 3 times root 7. Okay. Plus root 7 times root 7 is root 7 squared, isn't it? Okay. Now look at this. Root 3 times root 7 plus root 3 times root 7. Can I write them as 2 times root 3 times root 7? Fine, because 1 root 3 times root 7 plus 1 root 3 root 7 is 2 root 3 root 7. And this is root 3 squared plus root 7 squared, isn't it? Okay, now we can simplify. Root 3 squared, remember in the previous one, it is 3 plus 2 root 21, 3 times 7, 21, plus Root 7 squared is 7. Now, can these two be added? 7 plus 3, 10. So, it's 10 plus 2 root 21. That's our answer. Got this point clear? Okay. Thank you for watching this video. Hope you understood the concepts of operations on real numbers. My name is Askar Khan, and our mission at Wisdom Outline is helping you learn. If you're looking for math coaching classes, you can contact me at the number given in the description below. Thank you. Do subscribe to this channel and share it with your friends.